Okay, this is a quick tutorial on how to set up a case in UFO-CFD with rotating wheels, and this is just the Octree version at the moment. So the first thing, that if you want to have rotating wheels, or at least specify rotational velocity on the wheels, then they need to be separated out from the rest of the geometry. So in other words, in this case, I have painstakingly separated out the front wheels and the rear wheels. They are completely separate now from the main body or the main fuselage. So it's okay if the geometries are touching, but they need to be specified as separate STL files. So that's the first step. Then the next bit is some fairly quick and easy modifications to the input file. So instead of one geometry, you've got three geometries now. So you need to have this number changed to 3, and then you need to list the files at the beginning here. So you've got the fuselage boundary, that's the main fuselage, and then you've got front wheels STL and rear wheels STL. And here I've specified binary STL format. I'm saving in binary format the VTK files, and that's about it. Until further down in the file, the other main change is that you need to switch rotational on. So this value here, W rot, needs to be set as 1, which is normally 0. And the next bit is literally just specifying the file numbers for the front and rear wheels. So this is just number 2 and number 3. So that's specifying that the second and third STL files are the wheels. You need to specify the angular speed, which takes a few minutes to figure out, but angular speed, or omega, is bound by this relation V equals R omega. So once you know the radius of the wheels, then you need to calculate an omega, which corresponds to the forward velocity of the vehicle. So omega equals V over R. So in this case, omega is 8c divided by the R, which is about 0.75. So that gives you an omega of 107. And that's just to make sure that the wheels are rotating at the same, the tangential velocity on the surface of the wheel is the same as the velocity of the vehicle. And then you need to specify the center coordinates of the front wheels and the rear wheels. So simply by looking at the geometry in PowerView, if we just go to front wheels, for example, and take a slice of them, you view it side on, then just by taking a slice, it will calculate the center point of the wheel. So you can use that as a good estimate of the center point. And then the same thing for the rear wheels. You just take a slice, and then that will give you some coordinates. And it's just the X and Y coordinates that we need. So the Z1 have been set to 0. So these are the X and Y coordinates of the front wheel and the X and Y coordinate of the rear wheel, and that's it. Then having set that, and then when it runs, it will separate out the any of the cut cells which have been cut by the front wheels or the rear wheels will be in a separate category, and on those cells a rotational velocity will be applied. That's how that works. And in this file, the only other thing that I've done is to set up a refinement box. So just one box with level 8 refinement, and then specify the dimensions or the location of the box. So that's a separate issue really. And once you've done that, then you can run the case. And when the case is run, then you can do a quick check once you've got a solution to check that the rotational velocity has been applied to the wheels. And I'll come back to that a bit later.